So in this video, I'm going to delve a little bit deeper into quadratics and just give you more facts about the equations and what we can gather from the equations themselves. So what I'm going to do first of all is just write down the standard form equation that we looked at in the episode previous to this video. So remember writing it down as y equals ax squared plus bx plus c. Now that was the standard form, and the equation I talked about was y equals x squared. That's the most simplest one we looked at. Now this video we're going to talk a little bit about what exactly does this a represent, and what exactly does my c represent. I'm just color coding it here, so when we look at it, we can look at it. So first of all, I'm going to throw up an equation here. So let's talk about this one right here. Let's say we had y equals negative 2x squared plus 4x plus 4, for example, right? So what's the a value here? Negative 2. What's the b value here? 4. And the c here is also 4. So what I want to talk about here is what the a value does. So I'm going to write another equation on this side. What I'm going to do is I'm going to change the a value, alright? So y equals, let's say 2x squared this time, plus 4x plus 4. So we're going to draw a grid here, as well as a grid here. So what I'm going to do here is I'm going to go ahead and make a rough sketch of the graph right away. So I'm not going to make a table of values for each, which you should do, but it's just going to take too much time. I'm going to go straight to drawing these graphs. And you, from just recognition, tell me if you notice a difference. So first of all, there is a difference in my a values. Here we have a negative 2 as my a, and here I have 2, just 2 as my a, right? Positive 2. So if it was a negative 2, guess how it would look like? Let me just define my y and x. And if it was a positive 2, it would look like this. Now, you see the difference between the two? A negative 2x squared, my graph looks like an upside down U. I have a positive 2x squared, my graph automatically turns into a normal U shape. So, if you haven't recognized already, my a value determines which way my graph will look like. So over here, we have our vertex, right? Vertex right there. Maybe I should use my blue one just to signify. So that's my vertex there, and my vertex here. Again, what's a vertex? Vertex is the point where I can cut it, and the two sides will look exactly the same. Now, here, my vertex is called a maximum point. And you might ask what that means or why I'm talking about maximum points. Maximum point, all I'm saying is that this is the biggest point on this graph in terms of the y value, right? The y is this is a positive number. In this case, it's 4, and I'll get to that as well. So the y here, or not 4, my bad, but the y here, this is the highest or the biggest y value there is. It's a maximum point. Every single y, look, it's decreasing, right? We go into the negatives, it's all decreasing. So whenever I have a negative a value, so I'm going to write that, a is negative, there's a maximum point, and my graph opens downward. So all that means is that opens downward. So all that means is my graph is an upside down U. It opens down, right? If I open the graph here, it starts going down from my maximum point. So my a is negative, I have a maximum point, and the graph opens downward. Now let's look at this one here. I have a value that is positive, so I can write that. A is positive. I almost am running out of room here, but put that one in there. So again, if my a is negative and I have a maximum point, what do you think if my a is positive? What will my vertex be called here? It's going to be called the minimum point. And again, it is called the vertex, but just to be more specific, it's a minimum point here. And if the graph opened downward here, the graph will open upward here. Opens upward. So essentially, what my A value tells me is which way the graph is going to open. If my graph is negative, if my A value is negative, which it is in this case, it opens downward. I remember it as if it's negative, it's down, right? Negative is usually found in the down below region. So if it's negative, my graph opens downward and I have a maximum point. Like my vertex is going to be the maximum point. If my A value is positive, right, my graph opens upward. Positive up, that's how I remember it. Again, if my A is positive, I have a minimum point as my vertex and it opens upward. And before I move on and talk about what the C signifies, I'm going to talk about two more things. So my vertex here, as I said, is the minimum point here. My vertex is also called the axis of symmetry, or the axis of symmetry is the x value at the vertex. So over here, let's say the axis of symmetry is right here, right? So whatever the x value is at this point, that is my axis of symmetry. So that's just tiny side. We'll talk about it more when I do a few problems related to this unit, but just throwing that in there as we go about it. Now you might ask, what does the C represent, right? So we did the A, right? In the blue, we have the A. Talk about what the A value is. The C is actually something you should remember from linear relations. It's called the Y-Intercept. So whatever the Y-intercept is, it's wherever it touches the y-axis. So in this case, what's my C value? It's 4, right? It's also the same here. So see that wherever this is going to be my y-intercept. So 4 is my C value here, and my y-intercept is going to be 4. And it's also the same here. So my graphs both have the same, these two both have the same y-intercept because the C value, right, is my y-intercept, 4. So again, what did we learn so far? My A value shows me my which way the graph is going to open, and my C value tells me my y-intercept. So if A is positive, it opens upward. If A is negative, it opens downward. What does the C value tell me? The y-intercept. So now that we have this down, and we know what my A value means and what my C value is, we're going to talk a little bit more about a couple more properties I'd like to talk about, and then we're going to do a few problems, and just to test ourselves of the knowledge we have so far. So I'm going to erase this so far. Again, feel free to scroll back or whatever you want to do to learn this material. You might want to copy it down as I write stuff down. If you want to do that, that helps. So if I have another graph, right, like that, and let's draw the graph like this. Okay, so I don't have an equation for this or anything. I'm just going to highlight some important properties. Okay, so what can we infer about this graph? It opens downward, right? We can see that because there's an upside down U. So we can say the A value for this is negative, right? If A is negative, it opens downward. And the y-intercept, I don't know, but let's say the y-intercept is right here and it's 0, 3, my bad. So the y-intercept is where it touches the y and x is 0, right? So y-intercept at 0, 3, right? So we talked about the A value, we talked about y-intercept is 0, 3. And another thing, if the A is negative, you can also say it opens down, opens downward, down, whatever you want to say, but it opens downward. That's something we want to talk about. And the next little thing I'd like to talk about are these points here. So whenever a graph touches any of the axes, those points are usually important. Like the y-intercept, right? It touches the y-axis, we treat it as the y-intercept, and it's important. So when it touches the x-axis, right? Right here, this is also quite important because these right here are called the zeros, alright? So let's say this point right here was 4, 0. And this point right here, let's say, was negative 2, 0. Right? My y value is 0 in both cases, but x, there is a value. So these right here are called my zeros. So this is also called a 0. Alright? Wherever it touches the x-axis, it's called a 0. Alright? And again, So the zeros are at, I can write that up there, zeros are at negative 2, 0, and 4, 0. So negative 2, 0, and 4, 0. And this right here is my vertex, right? The maximum point in this case, right? Because my A is negative, it opens downward. My vertex is negative, so that's my vertex. And that is my also maximum point, right? Because the A is negative. So hopefully, if you've been following along, I know I'm going quite fast because these videos are supposed to be short and just supplementary material. Hopefully you're understanding how we can identify specific things on a graph, right? Wherever it touches the x-axis, those are called my zeros. Wherever it touches the y-axis, it's called my y-intercept. And I can also find it from the C, right? The C represents my y-intercept. And if the A is negative or positive, it tells us which way it is opening. So all those things are specific things we should know about quadratics, right? So hopefully this example gave you a little bit of more of an understanding, and in the next few videos I'll actually take a few textbook questions that I've found and I'll actually work through them, so you'll see some examples of questions and you'll also see how you would work through the answers for those questions. So hopefully you watch the next few videos as well and you watch the previous one, and yes, so I'll work through a few more problems in the next upcoming videos, and we hope to learn more.